Angular signals are a new reactivity concept in Angular. In this video, we'll explore what they are, how to use them, and integrate them in a video calling application. Here's the example app that we built. We can enter a call ID, join the call, and see... Oh, sorry, wrong call. Hello and welcome to this video on how to use Angular signals to build a real-world application, in our case a video calling app. We learn about the different types of signals that there are, how to use interoperability with RxJS, and in the end we'll build a video calling application using the Stream Video SDK. But first, let's take a look at what Angular signals really are. They were introduced at Google I/O 2023, and I'll link the announcement video in the description. The baseline is that they are a new concept for reactivity in Angular applications, so they can be used for things like state management. There are three important elements when it comes down to signals. The first one is the signal itself, which is basically a wrapper around a value that notifies their consumers whenever a value changes. The second one is called a computed property, which is again a signal, but it derives its values from other signals. So whenever these signals change, the computed properties will be reevaluated. And the third one is called an effect, which is simply an operation that runs whenever one or more signals change. Now, there are more elements to signals, such as signal inputs or signal queries, but at the time of the recording of this video, they are still in developer preview, so we won't cover them here, but I'll add the documentation for them in the description of the video. Now, there's one elephant in the room, which is RxJS, which is heavily promoted by Angular itself as one solution for reactivity. And I'm glad to inform you that interoperability between Angular signals and RxJS is excellent, and we'll cover an example of this in this video. So let's first look at a simplified example of how signals work, and then we jump into creating the real-world application. But hold on. Before we start with that, I need you to like this video and subscribe to the channel, because we noticed that a lot of you are watching these without being subscribed. Thanks a lot for that. It's always best to learn with an example, so let's jump into one. On the right, we see a very simple Angular application. It simply shows a number, the number squared, and has two buttons, one which sets the value to 8 and the other who increments the value. On the left, we see the markup for this, so we have the count, which is one of our signals, as we will see in a second, so you can access them with parentheses. We have the squared value, and then we have a button clicked and an increment function. We see that when we set the value to 8, it will jump to 8, the squared value will follow, and if we increment this value increases and the other one gets computed as well. So if we refresh this, we see it jumps back to 0. Now, how does that look in code? So we have the app component, and first we define a signal like this. It's simply saying we want a signal and the initial value is 0. It's smart enough to detect that this will be a number. Next, we can create a computed property with this syntax. Now, the cool thing is that it will automatically detect which signal it depends upon and execute this only when this value changes. So here we say, whenever count changes, update the squared value to be the square of the current count. The last example that we have is the effect. So we can define it like this, and then we say whenever this.count changes, we want to lock this to the console. Now, there are other use cases where this is helpful, such as in logging analytics data or syncing values with a database. The last interesting thing is the two functions here. So in button clicked, we update our signal with the .set function, which sets it to a certain value, 8. And in the increment, we take the current value and update it to be +1. So it captures the current value of the signal and lets us work with it, in this case, increment it by 1. So let's see it in action. We have the set to 8 function here, which sets it to 8, and if we increment, We see this happening. Now let's look at the console. And if we take a close look here, we see whenever our value changed, it is first 0. So it's executed initially before anything changed. And then whenever we see changes, we increment this will be updated. Very cool. So the syntax is pretty straightforward. We can define our signals, our computed properties, and our effects in a very nice way. But seeing it in a simple sample application like this doesn't always show the full picture. So let's create a video calling application using Angular signals. The only prerequisite for this project is having NPM in a version higher than 8.5. So let's jump into the console to create the project. We can create a new Angular project using npm init add Angular, and we call it video calling app. We can select which style sheet we would like to work with. Let's keep it simple and just use CSS. We don't want server-side rendering. So let's wait until this is installed. Once that is finished, we can cd into the project folder and install the only dependency that we have, which is the Stream Video Client. We can quickly jump to the website to see that there are a lot of SDKs available for the different platforms. So there's React, iOS, Android, React Native, Flutter, Unity, and also the low-level SDK, the JavaScript SDK that we can embed into any SDK that we like, in our case Angular. So we will explore how to integrate this, which is very straightforward. And since the installation has already finished, the last thing that is interesting is that we want to install the Angular CLI, which we can do like this. And this gives us a few convenience options that we will see in a second. So we can generate components or services from this, which comes in very handy in just a second. So with that, we can run npm start. Our application will be served on localhost 4200. So let's open this up. And we see hello video calling app. The setup worked. So let's jump into adding real code to the project. The project is set up. And since we installed the Angular CLI, we can now conveniently add components and services to this. The project is set up. And since we added the Angular CLI, we can now conveniently add components and services to it. So let's jump into VS Code, and we have the project structure here on the left. And there's the app component that is initially introduced, but we're interested in adding a service first. So let's head over here and say ng generate a service, and we call it the calling service. We run this, and when we take a look, it automatically created a service TS file and a testing file for this. We're not interested in the testing file for now, so let's open up the service and make some room and start with the implementation. Now what we need to do in this calling service is we need to initialize the Stream Video SDK. We need a few credentials to do this. But luckily, we can head over to the tutorial website here for the JavaScript video calling tutorial. I'll add a link in the description. And we see how we can set up the client and a call, which we will do in just a second. But if we scroll further down, we see we get some credentials to try out an application with. So we get an API key, a token, a user ID, and a call ID, which we will use later on to initialize a call. And we can even join the call from the web to test out whether our code works, which we will also do later. But since we have this, we can now copy these values and add them in our application. So let's jump back to VS Code. And first we add a client, which is of type Stream Video Client. In the constructor, we then first initialize the API key. We copy over the token from the website and add a user with a certain ID. Finally, we can set our client using the new Stream Video Client object and handing in the API key, the token, as well as the user that we just created. Once we import the necessary objects, we have our initialization code already working. The setup project for the calling service and the Stream Video SDK has been pretty straightforward. Now let's jump into joining a call, and for that we need to add a form to our application to enter a call ID that we want to join. Now before we add the UI, let's think about the architecture that we want to have. In our service we want to have a call ID which we can set from the form, and then we need a call that we want to join in some form. And of course, we want to use Angular signals for that. So let's jump into the calling service first and think about what we need to add. First, it makes sense that we add a call ID, which will be a signal. This can either be a string or undefined. Whenever this value is undefined, we will show our form, and whenever this changes, we automatically show our call. Now we want to leverage signals and the powers that comes with them. So let's think about that for a second. We can set the call ID. Whenever we set this, we want to join a call. And then what we can do is, whenever we want to leave the call, we can simply set the call ID to undefined and reacting to that by leaving the call. So we can use a computed property for our call. We have the call. We set this as a computed property, which is either call or undefined. And now we make it dependent on the call ID. Now the cool thing is that computed properties automatically detect which signals they depend upon. They can even depend on multiple ones, and we can define whether certain ones should be tracked or not, but we won't cover that here. So we get the call ID first, and then if the call ID is not undefined, we can initialize a call using the Stream Video client like this with the current call ID that was just set in the signal. We can then join the call and activate or enable our camera as well as our microphone. We then return the call, and with that set our call property here. Now in the other case, if the current call ID is not set, or specifically is undefined, we also set the call as undefined. Now the last question remaining is, how do we set the call ID? And for that we can create a convenience function here called setCallID, which is either a string or undefined as a parameter. And if it's undefined, we want to leave the call, and afterwards we set the call ID to the value that was handed to us. Now if we add imports for computed and signal and the call, everything is green, we have no errors, and with that we can continue and build up the UI for this. For this we open up the app component TypeScript file and first get rid of the title. We then add the calling service as a class property here and import it. And then in the constructor, we add the calling service and set it. And the last step is to add a setCallID function that calls the same one on the calling service. Now that we have the logic, let's jump into the template code for this. We open up the app component.html file and start off with a blank plate. First, we wrap the router outlet in the main class. Then we can add a new section here, which we call the join section, and say we want to only show this if the calling service .callID is not there. So when it's undefined. Then we add a join call form, wrap it in a div, and set a label for join call, and add a input which we give another ID, and set the value to call ID and give it a placeholder of enter call ID. Finally, we add a button with a click property to call the function that we just defined. With that, the UI is pretty much ready. We only need to change one more thing because the ngIf doesn't work like this. We need to import the common module for this. And with that, everything runs green and we can take a look at how this looks. For this, we jump back into the browser and we already see that our form is there. We can enter a call ID. Let's use this one, and we can tap on the join call button and it will disappear because our call ID is now set. And with that, it will disappear because the ngIf will be executed. Now you might realize that when I refresh this, we have a bit of custom styling here. So taking a look at the app component CSS, there's a bit of CSS involved. I won't cover this in the video, but you can check out the GitHub repo. I'll add the link in the description for the full styling, but this would break the scope of this video, so please excuse that. We can now enter a call ID and our application will react to this, but now we also need to render the call itself. So let's jump back into VS Code and generate a new component and give it the name call. You see it is created and we get a new set of files here. So let's first start off with the HTML for this. We close off the terminal, we don't need it right now, and open up the call component file and close the sidebar. We remove the default code that came in and start off by adding a section and putting in a container div which gets the class participants. Now we want to show the participants of the call. Now we want to show off the participants of the call one by one. So let's add a ng container and use ng4 to iterate over the participants in the call using track by with some session ID. We'll add the logic for that in a second. And for each participant, we want to show some UI, which we will add in a second, but let's already put it in using the app participant here and inputting the participant that we get from the for loop here. Now we also want to add a few call controls. So let's create another container for this. We add a toggle microphone button, a toggle camera button, and a leave button, which all call functions that we now need to create. So we jump into the call component TypeScript file and do our magic here. The first thing we want is to input a call specifically into this component. So let's use the Angular input and set it as required true and hand in the call. We also need some form of participants and we can use a signal for this again. It's just an array of stream video participants here. We will implement that in a second, but let's hang on first. We have a constructor, we need the calling service inside there. We add a function to toggle the microphone, which is actually pretty straightforward because the Stream Video SDK has nice convenience functions for this. So we can access the call, access the microphone object here, and simply hit the toggle function. Same goes for the camera and for the leave call. Remember that we implemented the logic in the calling service. Whenever this is undefined, we will actually leave the call and then update our call ID to be undefined, therefore showing the join call form again, where people can enter a new call ID. The last function to add is the track by session ID. Remember that this is part of the ng4 loop here, which we use to iterate over the participants. And since we add the session ID to track which participant is which one, we avoid unnecessary renders and rendering loops. Special thanks to my colleague Zita for pointing that out. Now I mentioned the participants object here, right? And this is a signal. However, in the Stream Video SDK, since this is just a low-level client, it actually makes use of RxJS. But luckily, Angular comes with an interoperability for RxJS, which we will add now. So we can import the toSignal function from the Angular core RxJS interop module. And this makes it really easy for us to convert the RxJS observable that we get from the Stream Video client to a signal. So let's take a look at how we can do this. For our participants, we set them to a toSignal call to the calling service .call. We access the state and the participants here, which is simply an observable over an array of Stream Video participants. So just what we need. We call the require sync to be true, and we can guarantee that this will be called at least once. So we get the initial participants, and whenever they change, this value will update. It will be converted to a signal. The signal will be read by our container here in our ng-for loop, iterating over the participants and showing each one. So I think this is a very elegant solution requiring very few lines of code, but creating a really powerful system already. Again, we need to import the common module because we use an ng-for loop. Now, if we head over to our component HTML, we see that we're still missing the app participant. So let's create a new component. ng-generate component, call it participant, and see it being created. We open up the Explorer here and we see our newly created participant component, which is still not there because we need to import it. And with that, we can access it. The only thing remaining is we need to add the input of a participant to our component. So let's open up the TypeScript file here and close the sidebar first. Now here we need to add a few more elements because we need to bind all the video and audio elements to the streams provided by Streams, no pun intended, Video SDK. So let's start. We have a participant that we set as input to our component. We already see this makes this code work. So this is the first step for us. Now I mentioned that we need to bind the video and audio streams to elements in the HTML. So we need to access them, and we can do that using the viewchild declaration for a video element and the audio element. We will define them in a second in the HTML. Now when I say we need to bind them, we also need to make sure that they are cleaned up properly. So we also need to be able to unbind them. So let's add references to unbind the video and unbind the audio elements. Next, we add a constructor. We need access to the calling service because we need to have access to the call itself. Now, the way this will work is whenever the view appears and we know the participant is there, we will say after the view is initialized, we will first bind the video element to the native element here using the current participant's session ID, and we want to specifically select the video track. This function will return the cleanup function, so we set this to our property that we just created to be able to call that later on. We do the same for the audio element, which is the same code. We set it to the native element, set the session ID as well. Now the last thing is we want to clean this up. So we use the ng-onDestroy function. Whenever our component is destroyed, if the unbind video and unbind audio element cleanup functions are there, we call them, therefore cleaning up nicely. With the logic done, we can jump into the necessary HTML code for this. So let's save this and open up the participant HTML. First, we get rid of the default code and add our own HTML. This is generally straightforward. So we first add a container div, and inside we add a video element. Using the hashtag here, we set its ID to the video element, which we can then access using the view child that we can see here. We give it an ID and we attribute the session ID to the current participant's session ID, set autoplay to true. And we also need an audio element, again the same one, using the audio element hashtag. We can access the view child here very conveniently. We again set the ID, and this is enough to bind the audio and video streams to the elements that we just defined. Lastly, we add the participant name as a text so that we can identify which person in the call is who. We can save here, and we're almost done. The last thing is we need to actually show our call inside of our app. So let's switch over to the app component HTML. We add a new section here saying if there is a call, so if our signal of call inside of our calling service actually is not undefined, we can add the app call, and we bind the current call using the calling service.call function. And we know it's there, so we can use the exclamation point here. Now this is not yet imported, so inside of app component TS, we need to import the call component. We save and we jump to the browser, and we see our form popping up. Now for the call ID, let's switch back to the tutorial page and actually copy the call ID that we get here. We can now enter the call ID here. We copy paste this and hit the join call function. We see our image is initialized. We can move here. We see the name. We can deactivate the camera and activate it again. We can hit the toggle mic function, but we can't really see if this is actually working as a real video calling app. But luckily, if we switch back to the tutorial, we can join the call from the web app. So let's hit that button. We can join the call. We can see the both of us. Inside of the call, we can see speaking indicators here. And if I switch back to our app, we see there's both us and another one who's called Brakis. Both of them are in the call. We can toggle the mic. We can see we're now muted. We can click it again, not muted. We can deactivate the camera here, which will freeze this frame. And we can leave the call and the other participant disappeared. We can do the same here in the app, call the leave function, and we're back to our initial form. Everything is working as expected, and we have finished the implementation of a video calling app. So let's sum everything up. In this video, we have achieved quite a lot. First, we have learned about Angular signals, about the signal, the computed and the effect properties. We have learned how to use them in a sample app and then build up a full video calling application from scratch using the Stream Video SDK. We've also learned how to add interoperability with RxJS, which is a very common framework used in many SDKs. I hope you enjoyed the video and learned something new and had some fun along the way. I surely did. If you did enjoy it, then please consider subscribing to the channel and liking the video. This really helps us. But for now, I want to thank you for following the video and hope you have a great rest of your day. Bye bye.